Okay. So we are grade 10.6. Okay, so we know our formulas, and I said to you, sometimes they'll give it to you, sometimes they won't, so it's just better for you to know them. And then we also looked at what perimeter was and what area was. What I want you to do is to quickly go to those two terms that we wrote down. So I'll quickly find the PowerPoint for you. And you'll see that I've added two things into it. So we said that perimeter was the outline of the shape by adding all the sides together. I've added this unit here. I'm talking about a singular unit, millimeters, centimeters, meters, kilometers. Okay, obviously we are measuring a distance, so those are the kinds of units we would have. For area, since we are multiplying centimeters by centimeters, we'll end up with centimeters squared. Or millimeters with millimeters, we'll end up with millimeters squared. Kilometers by kilometers, kilometers squared, and so on and so forth. Okay? Then the other thing that I want you to just make a note of over there somewhere is that when we are adding or multiplying, we have to deal with the same units. So we can't go centimeters times meters or millimeters times kilometers. We always have to have the same units. So I'll put a note at the bottom quickly. And I'll make it red. Calculations have to have the same units. So calculations have to have the same units. So the ones we practiced yesterday were easy peasy. They were all in the same units, so you didn't have to worry about it. But very often, actually almost all the time, I'm going to throw in different units because it's a perfect place for me to assess your conversions from millimeters to meters or centimeters to millimeters or whatever else. Okay? So then yesterday we looked at, did we calculate all of them? Did we finish all of them? Okay, so today I just want to add some extra notes. So I'm going to go back to the document camera. So you're going to be writing notes in your book. Okay. So this is pertaining to circles specifically because for some reason learners don't like circles. Okay, so circles, so it's a note on circles. We can obviously calculate the area and the perimeter, just like we do with every other shape, and they also have specific equations. But now, in order to actually understand a circle nicely, we need to understand the different parts of a circle. Now, I can give you information about the diameter of a circle. Now, the diameter of the circle goes from end through the center to the other end. That is a diameter. So in pink, I have my diameter. Okay? And in green here, from the center, so from halfway to the edge, I have my radius. So a diameter is equal to 2 times the radius or a radius is equal to half a diameter. Just a quick refresher. So when I'm asking for perimeter of a circle, it's got a fancy name that is unique to a circle, and it's called the circumference. Okay? So my perimeter is also known as the circumference of a circle. So perimeter, also known as circumference of a circle. And my circumference formula is 2 pi radius. My area is just still called area, and it's called pi radius squared. Now, how do we not get confused between these two if I don't get given the formula? Okay? Well, area is a dimension times another dimension, right? So my area's term was when we multiply two adjacent dimensions. So wouldn't radius times radius therefore be multiplying two dimensions? I'm multiplying, right? A dimension of radius times another radius. What is radius times radius? It's just radius squared. So as soon as you think of area, we think of multiplication, and therefore we are thinking of the squared radius formula. Whereas the one without the square has to be my perimeter. Now pi is a unique number. It is not a variable that can change. It is a unique number. And pi itself is a funny number because it actually hasn't been solved yet. We know that it's 3,142 and we know quite a few of the decimals, but we haven't found where it stops yet. And we are already in the thousands. People do whole thesis on this in university. But now obviously we don't expect you to know 1,000 decimals, and your calculator is not powerful enough to do 1,000 decimals either. So we do use a rounded off value. Now the rounded off value that we use most common is 3,142. Now that is a rounded off value. I want you to go on your calculator. I want you to press shift and your pi button, and I want you to press equals and then your SD. So you will see that your calculator actually has 1, 2, 3, 4, 5, 6, 7, 8, 9 decimals for pi. Pi still continues for hundreds more decimals. So even your calculator is rounding off. Even if I go to a more powerful computer, it will round off. Even more powerful a supercomputer, it will also round off. So if I don't give you a pi value, you would press shift and find pi, and it will use all 9 decimals in your calculation. But we use it to 3 decimal places if I give you pi. And you can see why I say 142. Because the 5 is my fourth one, I round it up so that it is 142. So if I, in my scenario, give you pi, you have to use the one that I give you. If I don't give you pi, then you use your calculator. So I'll just, very important, NB, if pi is given, must use that pi. And that pi can change. I can make it 3,14. I can make it 22/7. I can make it anything I want. But if I give it to you, you must use it. So are we going to look at an example, a wordy example, so a word sum? I want you to calculate the circumference and the area of a circle so circumference in centimeters and area in centimeters squared of a circle with a diameter of 90 millimeters. So we are going to do it together, so don't freak out. But this is a very common scenario. So it might not be as blatant where I tell you circumference and area, but it will, I am specifying the unit that I want. So I need to answer in the unit that I'm asking for. So if I want my answers to be centimeters, but my diameter is in millimeters, can I just take that millimeters and put it into the equation? No. I'm going to have to convert to centimeters first. Now, how many centimeters is 90 millimeters? 9. How do we get that? We divide by 10. Anyone still writing? Peace is still writing. Okay. So I'll just move that up. So my situation is still there. Okay, so diameter equals 90 millimeters divided by 10 equals to 9 centimeters. And I'm going to give you a tip that will save you a lot of stress in the next 3 years. Always convert first. Jack, your question. Yes, you can. Always convert first. But now I have a problem. The information given to me was the diameter. My formulas use R for radius. So what do I need to do before I can even substitute in the 9 centimeters? I need my radius. I have diameter. We said that diameter was 2 times radius, or radius was? How do I find my radius from my diameter? It's half. So I just need to know that my radius is half of my diameter. Oopsie, we're in centimeters. So it would be how many centimeters? 4,5 centimeters. So timesing by half or dividing by 2 gives you your same answer. So you see how I already had to do 2 steps before I could even substitute in. Okay? So now I can substitute and calculate my circumference. And I am telling you, and I should have told you in our scenario, use pi equals to 3,142. So So I've told you that that is what pi is, so that's the only pi you are allowed to use. If you use your calculator's pi, you are not going to get that last mark because your rounding will be off. So I can say 2 times 3, 1, 4, 2 times 4, 5. So you can type it like that, or you can type it like this: 2, 3, 1, 4, 2, 4, 5. But please, 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 please ensure that you have every bracket if that's what you prefer to do. So you can type either one of those. 2 times 3.142 times 4.5. 28, 278 would be rounded off to 2 decimal places as 228. That is circumference, so is it centimeters or centimeters squared? Centimeters. And my answer has to be in centimeters because my question asked for centimeters. And I do the same thing with my pi. So I can say 3,142 times 4,5 squared. Or if I'm going to use brackets, be very, very careful. Your squared must only be on the 4.5. So if you do this, for instance, if you open a bracket, 3.142 times 4.5, close your bracket, and then square, you are actually squaring your 3.142 as well, and that will definitely give you the wrong answer. So that's why I said the square must only be on the 4.5. So my square is only on my 4.5. I don't even know if you can see that. Okay, answer. I have 63,6255. 2 decimal places would be 6. 3 centimeters squared. So now obviously that is easy peasy once you get the hang of it. But sometimes I throw some curveballs at you when I talk about half circles and 3/4 circles and quarter circles. Okay, so we're going to look at parts of a circle. So I'm going to make it in a table. I'm going to look at the part, the perimeter, or the, and the area. Anyone still busy with what's on the board currently? Okay, taking it off. So I'm making parts of a circle. I'm making a table if I can find my ruler. I write my perimeter in a bit of a funny place. So let's start with a quarter circle. Okay, so I only want a quarter of my circle. Now if I was dealing with area, that would just be a quarter of my area, right? I just want a quarter of my circle, therefore I want a quarter of the space on the inside of that circle. No problem. So there's my whole circle. But I only want a quarter, so I times it by a quarter. Area is no problem. But is the perimeter that easy? Can I just take a quarter of my original perimeter? So if I take my full perimeter and I only do a quarter, so my full perimeter for full circumference, and I only take a quarter, it is only that portion, right? But is that the only thing that I have there? Do I only have this random curve in the middle of the space? Or do I also have two lines that connect to the center of that circle? I also have, so that's the quarter of my circumference, because the circumference is everything around, but I also have 1, 2 radii that now form part of this this perimeter. So I would have my perimeter equals to, yes, I can have a quarter of the whole 2 pi radius, but I still need to add those 2 radii that form the wedge. If I have 2 radii together, what does that form? 2 times radius is that's just the diameter. Okay, so I'm just going to make a little note here. 2 times radius is equal to diameter. So I could have substituted that whole 2 radius with diameter. Let's look at half a circle. My area is no problem. I want half of the space on the inside. But if I take my perimeter and I half my perimeter, then I only get the curve. I still need to close that curve to make a shape, which is 1, 2 radii. And once again, 2 radii is also the same as a diameter. And my last one that I'm going to look at is, what if I have to do a 3/4 of a circle? Well, that's going to be a half plus a quarter. I need to close the shape. So my area, once more, I just want 3/4 of the space on the inside. Now if I take my perimeter and only take 3/4 of the full perimeter, I will have only my curve. But I need to close that shape with 1, 2 radii. And my 2 radii could also be changed out with a D4 diameter. Okay, before we go to complex shapes, we're going to practice some word sums. Anyone still writing? Okay. So if you have your textbook here, you can take it out if you want. It's on page 263. Otherwise, as soon as Josh is finished, I will put on the board. I'll also put it on the group. So we're only doing number 1, not number 2. Okay, A to L. You finished, Josh? Yeah. Okay. Let's make it a little bit bigger. Okay, so it says, calculate the area of each shape below, okay, and where necessary, convert the units to the smallest measuring unit. So if I get millimeters and centimeters, which one am I converting to? Millimeters. If I get meters and centimeters, which one am I converting to? Centimeters. So I just want to check. Okay, circle, okay, I will tell you, I'll circle it with a pencil. Okay, the ones that are circled, you will also do the perimeter, please. So A, B, not B, C and D, E, F, G, H, I, J, K, L. Okay, so it's just B that we can't do the perimeter. So how I would set this up is that I would do perimeter and area next to it. Then my next question, perimeter, area next to it. So we'll do the first one together. So it's exercise 3.5 from page 263 from the textbook. Okay. A says a square with a side of 14.3 centimeters. I want the perimeter. So you can go side plus side plus side plus side, or you can go 4 times side. So it would be 4 times 14.3 centimeters. 4 times 14.3 equals to 57.20 centimeters. I'll show you now. And then my area would be side times side, or side squared. So it'd be 14.3 centimeters times 14.3 centimeters. 204,49 centimeters squared. So that is my first one, where I have a square with a side of 14.3. There's my perimeter and area for number 1. So I want you to stick to showing your units, converting first if you have to, and 2 decimal places, please. So first convert if necessary. Show your units and 2 decimal places, please. So first convert, show your units, and 2 decimals. It is on the group as well as the board. I'm just waiting for you to write the example down. And then I want you to do the rest, please. And then tomorrow we can do the real, in the situation kind of questions. Okay, can I show the questions? Okay, I'll zoom in again, Morgan. Yes, you can. So remember, B, you will not do the perimeter, but you will only do the area for B. The rest, area and perimeter, please. So look at your formulas if you have to. Remember to convert. But I want you to leave a space for number B's perimeter. Actually, let's do that together. Okay, we're going to do B together, because also there's some conversions. So it is technically possible if I assume that this is a right-angled triangle. Okay, so if I assume, which you should never assume, but I'm going to tell you, triangle is right-angled. Therefore, if I have a base of, what did they say, 45 millimeters and a height of 6 centimeters, remember the base and height form the 90 degree. So there's my triangle. If I'm busy with a right angle triangle, I can use Pythagoras to find this missing side. I do that by saying, we'll call it x for now, 6 squared plus 4,5 squared, because it is 4,5 centi. Oh, we have to go to the smallest one, eh? So this one has to become 60 millimeters. So that's 60 squared, 45 squared, 60 squared plus 45 squared equals to 5625. But I don't want x squared, I need to square root. So I would square root 65625, giving me 75. And that's millimeters. So then this would be 75 millimeters. So now I can do my perimeter because I have all three sides. Pythagoras won't come up often, probably once in the next 3 years, but it can come up. So whenever we do area and perimeter, we will practice it. Okay? So therefore, my perimeter I can now calculate as saying 60 plus 45 plus 75 equals 180. What's my units? Millimeters. Anyone confused as what I did, doesn't remember Pythagoras? Then my area of a triangle, well, we know it is half base times perpendicular height. So it would just be half times my base, which they said was 45, times my height, which is 60. Gives me 1,350 millimeters squared. So note, please, I did it automatically and I realize that you are still learning. 6 centimeters times 10 gives me 60 millimeters. Okay, that's a centimeter. So the rest are all clear, has all the dimensions, you don't need to do anything funny. So C to I you can continue with, please. And I will also do it. Please ask if you get stuck. But very important, don't just sit and stare. Okay, I'm going to can I take this out? Are you still writing this down? Pieces still writing this down? Pieces down, Jack's still busy, Amy's still busy. It is on the group if you want to check it out in the group. So you both finished? Okay, there's your questions. Let me zoom in. Okay, so you're going C onwards, area and perimeter, please. Or perimeter and area. Use pi on your calculator. I lied. Use pi equals to 3,142. Because some of your calculators are different. So please use pi. Anything that has a circle, use pi equals to 3,142. So that is number K, J, I, G, and D. Please use pi equals to 3,142. F has another Pythagoras, so assume again that it is a right-angled triangle. Okay, we'll mark that first thing tomorrow. I got to H, so hopefully you are more or less there too. I won't force you to do this for homework, but I am just going to mark tomorrow, okay? So it is better for you to practice, but that's your decision to make.